Hello. I hope you're having a good day. Today I'm going to demonstrate my code and the application for the coursework 1, and this is a steganography tool. So this steganography tool can you takes the image and you can encrypt any data, any message inside of it, any text message inside of it. On top of that, it is protected by an encrypted password. So first of all, we are going to import some libraries. We import the imread and imwrite function from the OpenCV library in order to read and write the image. It is basically for the CRUD function of creation of compiling and encoding during the encoding of the image, because it's a computer vision library and it's very useful. And NumPy is a library. Basically we are going to be working with pixels, which means that there we are going to need a matrix because it will be very efficient, and NumPy accelerates the performance with matrix. And then we have base64 encoding. It is basically the module which will help us convert binary digits into text, which we can manipulate. Then we can revert it back to binary digits, then it will go back to image. And we are going to use the MD5 encryption for the password. We are going to use the cryptography Fernet for our encoding, and this is input. It is basically some error messages which I will show on later. So let's go to the main menu first. So at first, this is the main menu, and we are asked for so let me run. I will show you while it runs. So Python. So if I do this, okay, we get what do you want to do, encrypt and decrypt. So it's basically this main menu, and we can do two functions, either encrypt or decrypt. So if we choose one, it's going to go to encrypt and it's going to take necessary input. So the necessary input are input name, secret data, the data we want to encode, the password, and the output. Then we will try to encode the file with the password and encode. Basically we are going to call a function, and that function is encode here. So basically we get the file path, we get the text that is going to be secret text, and then we are going to put the output file name and password, and that progress bar is redundant for now. Then if there is no password, we have another function which is encrypt and decrypt, which basically hashes the MD5, and then it is basically without any password. It will work later on as well. And we can encrypt. We using base64. We will use Fernet to input necessary it basically looks for the least significant binary digits, so that it could replace it with the information that is our secret data turned into a key, which is this cipher key. Because since of the pixels there are 4 attributes. Those are red, blue, green RGB, and then there's a transparency layer. So there are 4 values to a pixel, and those pixel allows, among them there is always a least, one of them will be least significant, which will not affect the color that much, and the image will look the same. So that is where the information on the secret is going less. So that is how encoding happens, and this is how it is working on the loop. And finally it's going to be written with an output file image, which is going to be encoded into the file. Then decode, if we choose to decode, it will do the same thing. It's going to read and it's going to look through the loop, and then we are going to call so bin to str is this, basically takes the string and turns it into binary, and this does the opposite. This take the binary and turn into string, and these are called like many times, not many times, maybe twice each, I guess, for whenever it's necessary. So let's try and look at this, how this works. So we have this text and png. So it is important to know that this text.png, this only works on png files, and it does not work on jpeg, mostly because jpeg is a format which is compressed. Like whenever you save an image in jpeg, it does some automatic compression, which can modify or lose more data than intended. So we are going to be using test. So let's try to encrypt this. So we're going to do test, and since it's on the same folder, we're just going to write test.png. If it were somewhere else, you could have given the full path, but it's right here, so we don't need to. So secret data would be, this is for a video. Password would be 1234. Let's say output is output.png. Okay, so it's encoded successfully, and we have seen that there was a data loss of 0.03. So the program found 0.03% of least significant binary bits, which are the least significant pixel data, and replace those. Let's check them side by side. So as you can see, so there is not much any difference between them. Like they look identical, and it's invisible to the naked eye. So since we have confirmed that, let's try to decrypt now. Okay, we are going to run the same program, and we are going to go decrypt. Image path is output.png, and password is 1234. Decrypt data, this is for a video which we had secretly put here. So this is basically the program. I am happy to entertain any more questions. If you have more questions, please let me know. I hope you're having a good day. Thank you so much.